All right, quiz tomorrow. It'll be, how many questions? 10. What are the first, what's the first question gonna have? A, B, and? Okay. The second question will be interval notation. The third question, the third question will be, say, you'll have to simplify some of these radicals. How do you feel about things? All right, square root of 43. Now, tomorrow, at least when all these, write real for all of them, okay? They're all reals. Square root of 3, 43 is also n, irrational, and that's all there is there. You can write the word out. If you don't want to know what the letters mean from, the chart, I don't care. If you want to write them out, that's fine. So you can write real and irrational. The number 1, though, is quite a few more things, okay? And I wrote them up here for you, so they're in the directions for the quiz tomorrow, too, I'm pretty sure. So the number 1 is a natural, so n, okay? It's also a whole. It's also an integer. Z is integer. Q is rational. And it's a real. It is not an irrational. So it is 5 of those things. It's a natural, a whole, an integer, a rational, and a real. Everybody okay there? Letter C. It's a decimal. It's a real, and it's also a rational Q. That's it. Everybody okay there? All right. Interval notation. Interval notation for number 2. -15, comma, 3. This one's the easier of the 2. Is -15 have an equal sign with it? No, it's just x greater. So open x less than or equal to needs that guy, and you're done with that one. That is the easier of the 2. That is easier than number 3. Number 3 is a little harder. How do we feel about that? We're missing a few people.
Just, only one.
Okay. All right. All right, this one, the one you need to pay attention because it can be the trickiest, okay? So we're gonna go ahead and list again. We're gonna have -3. I'm gonna put an x. I'm gonna put 4, 5, and then an x. I'm not putting infinity. Do not put infinity. Because we're gonna be able to say x, okay? X just greater than. So x just needs to be what? Greater than 5. X greater than 5. That means 5, everything going that way. You don't need to write infinity. X greater than 5 means infinity. Does that make some sense into you? I hope it does. You don't need to write infinity. You just need to say x is greater than 5. What does it need? What does x need to be to 4 here? It needs to be less than and equal, right? And x needs to be greater than 3. Now you do need to do this part too. X such that these inequalities are true. Again, I'm going to give you another one of these to practice at the end, but this is the hardest one. Might be the hardest one on this section. Question?
No.
Okay. We're gonna practice another one of those, but does everybody get it? Again, I think that's the hardest one,
So I
so,
have a question.
yes,
Do I
please.
have to put the X1 there?
Gotta put what?
The X, one?
Yeah. That means X such that. That's part of set builder notation. Yes, you must put that right there. Inverse. What are we gonna add? What are we gonna add to get 0? So tomorrow you're right. Additive, add is 1/2. What am I gonna multiply to get what? 1. What am I gonna multiply the reciprocal, which would be? -2 over 1, or you can just write -2. So what do we add to get 0? What do we multiply to get 1? Write that down on your paper right now so you can study it, think about it. What do we add to get 0? What do we multiply to get 1? And that is for number what? Number 4. Still okay? Square root of 80. How about 8 times 10? Is everybody good with that? Still under the radical. 8. How many 2's is 8? There's 3 of them. What's going on with 10? Okay? Those 2's, 4 of them in there, and then a 5. Is everybody still hanging in there? What do we need? Sets of 2. So now I'll take this set out. Remember, that's 2 times 2 outside, right? So this is 2 times the square root of 5, which ends up being 4 square roots of 5.
I have a question.
Go ahead.
What if you did the factor thing?
I did.
I'm
But-
cool.
I just didn't do it. You went this way?
I got just the 4. I think, what did I do wrong?
You just gotta keep going with 4. 2 times 2. Then bring that down as 2, bring that down as 2. We got the same thing.
Okay. Okay.
You okay?
Yeah.
All right. I mean, we are getting the same thing there, just.
There they come.
All right. This one, you're gonna break it down to start with. Square root of 125 over the square root of 5. That's a quotient rule, we can do that, right? Now, simplify 125. I'm gonna go with the perfect square here, because 25 goes into that pretty easily, doesn't it? It's 25 times 5. So up top is gonna be 5, square roots of 5, I still have the square root of 5 underneath. Now I'll stop there, is everybody okay with 125 being 5 square roots of 5? That's 25 times 5, the 25 is the perfect square. We did a bunch of those, we did a Kahoot with them, didn't we? Now, what's cool about this one is what happens to those square roots of 5? Cancel. My answer is just 5. Everybody okay? On to the next problem here, number 7. Here we're gonna have to rationalize. Multiply both top and bottom by square root of 5. I'm gonna have 5 square roots of 5 over the square root of 25, right? Of course, the square root of 25 is 5. So now I'm down to 5 square Square roots of 5 over 5. Again, just like the previous problem, what can 5s do? Cancel. And this ends up being square root of 5. Now these last ones we worked on yesterday, didn't we? We worked on some of this stuff yesterday where we have to try to add them together or subtract them. To be able to do that, they must have the same what? Okay, so this one is square root of 18, square root of 50, but they're not the same, so we might have to do some work. What do we have to do first? To try to simplify those. 18. 18 is 9 times 2. 9 times 2. 9 comes out as a 3. So outside we have 3 times 3, which would be 9 square roots of 2. So 3 square roots of 18 goes to 9 square roots of 2. Square root of 50. 25 times 2. So it's going to be 5 square roots of 2. Don't forget, you have to take that 3 times 3 on the outside. That's how we're getting that 9. Now it's pretty easy candy, isn't it? 14 square roots of 2. $27. 27 is a bunch of 3s. There's 3 of them. There'll be 1 left in the house. It doesn't have a date, but we're bringing a 3 out. 3 times -2 would give me -6 square roots of 3 minus 75. Square root of 75. 25 times 3. So 25 comes out from 5. We have 5 times that. It's going to give me minus 15 square roots of 3. We have -6 of something minus another 15 of them. -21 square roots of 3. How are we doing? We still going okay? This is the one we've been waiting for. Yes?
Could you re-go over how you got -6 and -15?
Yes, I can. Okay? I certainly can. Let's start with -2 square roots of 27. Okay? So 27 is 9 times 3, which would be 3 times 3 times 3. Under the radical, we have -2, right? This set comes out. Boom. So now we're going to have -2 times 3 times the square root of 3. -2 times 3 gives me -6, and the square root of 3 comes along. That's how we did that one, okay? Now the other one was a 75. Square root of -3, square roots of 75. 75 would be 3 times 25. We still have the -3 out front, okay? And 25 comes out, so we're gonna have a -3 times 5 times the square root of 3, and that would give us -15. You follow that, hon? Everybody okay? Now, number 10, I think I made a typo, but that's the way it turned out. Guess what? Square root of 47 is nothing to do with it. Can we subtract these? Cannot. But 36 is a perfect square, right? So it does say simplify. So this would be -24 minus 2 square roots of 47 will get you the credit. Does everybody see why that's -24? Square root of 36 is 6. 6 times -4 gives us -24. Can't do anything else because 47 is stymied. good to go. How do we feel? Would you agree with me? I mean, rationalizing might be a little bit on like number 7, make sure you rationalize, make sure you, 8, 9, and 10, you get your right stuff there. But for me, the hardest one for you will probably be 3, so let's practice another problem like number 3, is everybody on board? Okay. I'm gonna give you a second. You can write this in set builder notation. Set builder notation.
The hard one.
This will be the hard one. Same process I would just showed you. So remember, just write -4, just go straight across. But instead, of wherever there's a comma, what are you gonna put? An X. Put your or, and now 10, X. Infinity, you're not right. Now, sometimes it might be helpful to write this out in a number line, but that might be more confusing for some of you. So if it is, don't bother, but I'll do it right now. -4, 5, 10. Okay, so this is -4 is included. It goes to 5 excluded, starts at 10, and goes to infinity. So number line might help you if you feel like you can use that, okay? So what's going on with 4? What's X need to be? Greater than and equal to, but it also needs to be less than 5, doesn't it? What does it need to be as 10? X needs to be what? Greater than and equal to. Now don't forget, X such that true. I'm gonna try one more of those. I think so too. Everybody okay with this one? No takers got it down that wanna?
We understand that's, what he has written there is 3 forms of the same thing.
Correct.
We're just changing its form. There's really no math involved.
Perfectly good advice. Those 3 things all mean the same. You want to write in a number line, if it'll help you, do so. If not, that's fine. So if there's an infinity, what should you put? Infinity or comma, what should you put? X. If it's an infinity or a comma, put X. That's a great way to think about it. Infinity or comma, put X. So what's this guy gonna be? X something 4 or 5 something X. You just have to figure out what you want for your inequalities now. If you need to draw a number line, I can help you. What's this number line gonna look like? That's what that number line looks like. So, x needs to be what to 4? Less than or equal, x less than or equal to 4. What does it need to be? 5. X needs to be greater than 5. Don't forget this part, x such that that's the case. Open for any questions or suggestions.
You better that time?
I went a little fast, they probably didn't have time, I'm sorry. What do we want? Anything 1 through 10, you?
Why'd you put the line in the less than the symbol?
I didn't. Under which one? By 4?
Yeah.
Because this is a closed bracket right here. That means included 4. This means 5's out. Remember that? Good question.
That's also why this circle is filled in. That bracket tells you that circle's gonna be filled in.
Anything else? Mm-hmm.
Why is okay? So like I get the whole like first part of it, like the x is less than or equal to 4.
Mm-hmm.
That part. But the other part, why is that greater than? And when it said is not.
Well,
Is it like
because
split?
look at the number line. It's starting at 5 and going to infinity. Headed this way forever. So that means here's your x. Does it need to be smaller than 5 or bigger than 5? X greater than 5.
Well, I know it needs to be that, but
Okay.
why is it like facing that direction?
Well, I could do it this way too. I don't wanna confuse you. Like we could write x and put 5 here, okay? And then say greater than. X
Okay,
greater
so
than.
it's just like the order.
You're just gonna read it x.
I don't know.
Read the F part first. It's okay both ways,
Okay.
but just make sure you think X greater. What do we want, anybody? Let's try this one.
You can get that by what you're doing. It's the same thing, but if it's 1/425, you know, the square, so 2/6 times. Okay, What multiplies together, you get both of them. So now I bring that.
Or square root of 3. I just did 506. So
Yeah.
I'm so sorry, I feel like I'm asking a dumb question.
No, go ahead.
You got 5, right? 3. Then here you have 3, 3, 3.
25 times 3
So. Now.
is 75. Square root of 25 times the square root of 3. Square root of 25 is 5. Square root of 3.
So I did 5 times 15. So I think
That's okay. 5 times 15 would be 5 times 15, but 15 is 5 times 3, hon.
oh goodness.
You see it? You can still do that. You just keep factoring and say yes, there's something.
3 and 3 and 3. Yeah. Just remember, there's your code right there. Yeah, this is that 3 already. So yes.
I didn't know. So what everyone doesn't have no, whatever.
Yeah. There is. What do you do?
I think.
So you can do 4.
what you get? I do this right now.
First of all,
That's already a perfect square. When it's already a perfect square. 200. Not 100 part. Perfect square.
That would why would you like 5 was at 0. So in the scope outside. But this one was very.
Well, that would be.
2 times 4 is 2?
No.
You don't want 2 times 5.
Single number is right here. And
Okay.
then we added this.
See, all prime numbers. We got it.
Square root of 200 is 100 times 2. 100 comes out as 10, so 10 square root of 2. Square root of 8 is 4 times 2, the 4 comes out as 2. 2 times 4 outside is 8.
Once you break them down, you no longer constrain yourself with these.
Everybody okay with this one? Everybody okay?
After you broke all these things down. Alright, I want it. You only know the 1, 2, 2, 5, 2, and 5, right?
Just like.
5, 5. That would give us 200. And I have it there. And there. Okay. So this is what's going to Take 2 times the 4 5s. So 2 times 5. This one did not have a partner.
Tough one. Challenge you a little,
Minus 4.
right? In the set over.
Break that down. The 8 one.
Those of you who are looking at it saying, oh God, don't worry, this will be a bonus problem. if I have it on there, but I'll challenge you a little bit. Take it up a little bit.
And then. So that comes up
So far. Right.
Okay.
to. Oh, and these two. So what do I multiply this by four. So you might still get.
So you've done with 4. Because it became 2.
I really messed up, sorry, hang on.
To the outside, right?
This needs to be negative, sorry.
So now.
That needs to be negative too, everybody.
So
So I get for making them up.
it was left inside. Which is not a part.
These aren't negatives. This needs to be positive, and that needs to be positive, and that needs to be positive. This needs to be negative. My bad, everybody. Stop. Let's start again. Negative infinity there to -2, -1 to 4, and 5 to infinity. My bad, I really screwed that one up.
Let's run back to the screen. Kind of better, yeah.
No, she might go back.
I still blame you.
I thought you know it was on. Sorry about that, everybody.
No, I said someone knocked on the door and we just looked at it.
Could be like
Oh, yeah. Yeah.
All right, stop back if you need any help. This tomorrow.
So, bro. I'd rather go there.
You're gonna work out?
I don't.